So we say that the universe consists of three known components. And I told you they are known. That doesn't mean there are no other components. These are the ones that are known by scientists. And the three known components of the universe, according to the Big Bang Theory, is number one, the normal matter, which contains about 5% of the mass of the universe. Dark matter, 26.8%. Energy, dark energy, 68.3%. So I told you now that it means that universe is more of energy than matter. The universe contains more of energy than matter. The universe is energy. I'll put that way. The universe is energy. Energy makes the universe. Energy is the cause for the existence of universe. Energy was not created. Energy cannot be created. Energy cannot be destroyed. Destroying energy means everything goes out of existence, including the universe. Because the universe itself is energy. The universe itself came from energy. So if you destroy energy, the total amount of energy you have in the universe sinks, dematerializes, because it actually came from energy itself. So energy is found in everything. You have energy in matter. You have energy in the universe. You have energy in every single thing that exists. So what are dark matter and what are dark energy? We are going to be looking at the majority of that. So the majority of the universe is made up of dark matter and dark energy. So for us to have this high amount percentage of this component of the universe, it means that these two guys must really be important than even the ordinary matter for them to contain more. That means they are more important than we, the planet, and so on, having just 5%. So let's look at why are they this important and why do they have this high percentage? Are they so significant to this extent? So let's look at dark matter. Scientists aren't exactly sure what dark matter is. You can see what I'm saying. So, but believes it exists due to results from experiments. Dark matter gets its name because it cannot be seen with any type of instrument we currently have. So they call it dark matter. They believe it exists, but they have not seen it. They cannot see it because this matter, though it exists, but there is no material in our ordinary matter that we can use to prove it. There is no material in our ordinary matter that we can use to foretell, to analyze it, to study it. So we now group this type of matter as dark matter. So you can't say what is in this dark matter. You can't say whether there are existence of other creatures or other planets in it, because for us to know whether there is a planet or other things inside this kind of matter, we must have an instrument that can help us to visualize it, but it does not exist. The instruments we cannot have. The materials we use to produce instruments are not powerful enough to make visible the contents of this matter. And scientists named it dark matter. Dark matter. When you say something is dark, it means it's so black that you can't see what is inside. So about 27% of the universe is made up of this dark matter. Dark matter attracts matter. So it is more like this matter contains what you call the antimatter that is always in antagonist with our ordinary matter. Remember, I told you from the beginning of this course that we have antimatter and matter from the foundation of the universe, and they are always warring against each other. We have lost so many millions of matter as a result of this war between antimatter and matter. So the matter that survived this war is what we have today as the solar system. They are the matter that survived out of others that were destroyed by antimatter. So dark matter, we can say, consists of this antimatter, and they actually attract our ordinary matter. Positive and negative we attract. So you should know they are word and opposite to each other. They are not similar. They are actually totally different from each other. Just say this as more of theories. There's no practical experiment to prove this. Because there's no instruments in our ordinary matter that can actually help us to give more explanation on it. So it's just a short note and we have nothing much to say on that. Then the next we look at is dark energy, which contains 68%, about 69% of the mass of the universe. Dark energy is something that scientists believe that it fills all space. They believe, they have not seen it. It fills all space. Dark matter turns out that empty space is more than just nothing. It is really dark energy. So when you hear the word space, what comes to your mind is emptiness. Nothing is there. Nothing exists in it. It's just full of emptiness. So when you travel to space, what you are expected to see is nothing but dark. But you see, there is no place, there is no region, there is nowhere where energy does not exist. Energy exists in you. Energy exists in the sun. Energy exists in proton, in neutron. Energy actually made it possible for proton to ever be formed. So even in where you call empty, energy is there. So what you say space is empty, what you have concluded by saying space is empty, meaning it has nothing, is actually not nothing. It actually has something. And that thing that it has is energy. That is why scientists call it dark energy. Dark energy. Because an assumption, nothing is there, but yes, we have energy. And this energy, we can't actually measure them. It's dark. No knowledge. When something is dark, it means no knowledge. You say I'm in the dark means I have no knowledge. So dark energy is energy that fills the whole space, but yet you can't see it. The theory of dark energy helps scientists to explain why the universe is expanding. Yes. It is not Earth. It is not ordinary matter. It is not antimatter that is making the universe to grow. It is not because the human population is growing at an alarming rate. It's not because the world is growing. It's not because the ocean is increasing or whatever. It is not because of the activities of the solar system. It is not because of our sun that is increasing or flaming up. It has no single business to do with that. Our matter is too small to have any impact in the universe in terms of this expansion. Matter is too small to contribute to the size of the universe, so small to contribute to even the mass, so small to contribute to the reason why the universe is expanding. What is making this universe to expand? If we look at the ordinary matter, it's too small. So we can't say it is the Earth. We can't say it is the Pluto. We can't say it's the sun or the solar system that is making the universe to expand. There must be something, and we can't see that something. We call that in energy, and that energy is a dark energy because it is beyond our knowledge. So all those empty space you found within space that looks as though nothing is in it, if this is to be the universe, and I told you that matter itself is just like a dot in the universe, even smaller than what I just drew here. This other empty space that you can find around, this empty space you can find around, let me make it, these are dark regions, everywhere dark, and covered everywhere, even the little ordinary matter you can find, these dark regions covers it. And we assume everywhere is empty. So if someone is so big and you are bigger than the universe, when you look inside the universe, I tell you, you will not see anything. You will not even see the earth. You will not even see the solar planet. You will not even see the sun. You will see nothing inside the universe because they are too small compared to the entire size. But yet we say that the universe is growing. If something is growing, that means it is something that is inside it that is causing it to expand. And we see that there is nothing in it. Almost everything is empty. That means there must be energy that is inside this empty space that we see. And this energy is a dark energy, and it is responsible for this expansion of the universe. That is where that word Big Bang theory is coming from. It's so big, it's a bang, and it is responsible for the expansion. It is not the earth. The earth is too small to cause an expansion. So it must be this empty space that we say has nothing, that actually has something. Something so big that is making the universe expand and make the earth even look more smaller. So around 68% of the universe is dark matter. Dark energy repels matter. It repels matter. So meaning they must be of same poles. Now, we are going to be looking more deeply into this Big Bang theory. Let's look at some evidence if this Big Bang actually exists. Remember what the Big Bang theory is looking at is seeing the universe as a singularity that started expanding and expanding and expanding, that has zero volume. And I told you why we say zero volume. Zero volume means it's as though nothing is inside. Whatever is inside is too small to be compared to its contents. So the universe is zero volume, a singularity that is growing, and at a certain time, it started reducing the temperature by about 1 billion, 100 billion degrees Celsius every 3 minutes. So as the temperature increases, protons begin to form, neutrons begin to form, and then they begin to unite together. Then we form hydrogen and helium nucleus. This hydrogen and helium nuclei begin to grow and expand and multiply, and now we have billions of them. It's through this hydrogen and helium nuclei that we begin to form the solar system, and everything that matter contains today actually came as a result of the cooling down of the universe. If the universe was to be heated up, everything that is found in the universe will dematerialized, we vanish, we cease to exist. So it's because the universe is cooling down. That is why something can form out of it. That is why proton can form. That is why neutron can form, because the universe is cooling down. But something is causing it to expand. That thing is not heat. That thing is an energy, and it's called dark energy. So what are the evidence for this Big Bang? Evidence for this theory. Number one, let's look at galaxies appear to be moving away from us. We have looked at that we have over 100 billion of galaxies. 100 billions of galaxies. So, and these galaxies are actually moving away from us. That means moving away from Earth. The greater the galaxy's distance, the greater their speed. So as the galaxies are moving far away from each other, they are moving at a faster rate. Why is it so? I will explain. There is actually an attractive force when two objects are placed together. There is a strong attractive force. So it will limit them from moving away from themselves. It will limit them from moving fast enough because they are pulling on each other. They are so close and they are pulling on each other, and their movement is restricted. But by the time these two objects are very far from each other, the attractive force is so little that now they are so free, they move so fast, faster and independent on each other. So as the universe are moving away from us, they move at a greater speed. So this observation supports the expansion of the universe and suggests that the universe was once compacted. So there was once a time that all the galaxies were all choked up in one corners in the universe, so choked up, billions of them. But right now we see that these universes are now separating, moving away, moving away. So as they are moving away, it's expected that the universe is expanding because of the galaxies are expanding. Please mind you, galaxies we are talking about now doesn't mean that there is something inside. Galaxy could mean something empty, just like we see. Emptiness does not mean nothing is inside. It just means there is full of energy. Energy is not nothing. Energy is something. In fact, energy is more of something than even you, than even me. You are made up of energy. Without energy, you will not be formed. So energy is more real than humans. Energy is more real than Earth. Energy is more real than the solar planet and so on. So you can't say energy is nothing just because the universe is filled with space of emptiness. And we are telling you that these empty spaces are full of energy, 68% energy. Energy is not nothing. Energy is something so great that it can cause a whole universe that we are insignificant in it and expand. The earth cannot make the universe expand, but this energy can make it expand. That makes this energy so significant. So based on the first evidence of the Big Bang, the galaxies are moving away. What do we mean by evidence? We are looking at why is the universe expanding? That is what we are looking at. What is the evidence that the Big Bang theory, which says that the universe is expanding at an alarming rate, even till now, the universe is expanding? What is the evidence? Number one, we looked at these billions of galaxies are moving away from us. So let's say this is the universe, and we have these billions of galaxies. So as they are moving away, we are expecting that they are stretching, pushing the walls of the universe and making the universe to expand. Why? Because they are now running at a faster rate, moving away. Let's say this is Earth. Earth is so small here, and they are moving away from us. As these billions are moving away, they are pushing the walls of the universe and causing it to expand continuously. As their speed increases, as they move far away from us, their speed increases. As their speed increases, they keep colliding with the walls of the universe, expanding the universe continuously and continuously. That is an evidence that the Big Bang theorists actually presented. So if this is true, that means there was a time the universe was not expanding. What made the universe not expanding at that point? Because it assumed that there was a time the universe was compacted. When you say something is compact, that means whatever it contains is actually crowded together in one corner. So there was a time the universe was compacted. Everything it's made up of, we are just crowded in one side. But now, this everything, as you call, are now moving away, spreading out. So as they spread out, they stretch beyond their walls and make the universe to expand. That is the first evidence. But do we have a proof for that? Let's look at number two. Number two is called the Doppler redshift. Doppler redshift. When you talk about Doppler in physics is let me give you an example of Doppler. When you say Doppler sound, for instance, if I have, I need you to understand what that word Doppler is. If I have maybe an ambulance, here is an ambulance with a siren. Whoa, 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 I'm making the noise. And here is a man standing close to this ambulance. The ambulance siren might be so loud that this person who is close might have to just close the ear because it's so noisy. But by the time the ambulance begins to move far away, what do you observe? The sound begins to drop. The loudness or intensity of the sound begins to drop. By the time the ambulance gets to a particular distance, it is not because the siren stops alarming. It is just simply because The ambulance is now so far away from the reach of this person, such that the person no longer hears the sound of the siren. Not because the siren stops making the noise, but because it has moved away. So that is what Doppler is looking at about. When you talk about Doppler, you are looking at the variation of frequency of sound or frequency of light. The same thing with lights. As the person is seeing these red ambulance flashes of light, very bright, but by the time this ambulance moves far away, he might actually not even see it again. Not because the light went off, but because it has gone so far that the light looks so dim and dim and dim and dim until it looks as though it's off because it's far away from its reach. So for Doppler redshift, what we are talking about is that the light from galaxies have lights. The light from galaxies appears to be more red than it should be. And the decreased frequency of light tells us that the galaxies are moving away from us. Do you see, just like the example I gave to you? So just assume this ambulance to be the galaxy, to be the collection of galaxies. And we, which is Earth, we have never moved away from one point for thousands of years now. The Earth has not moved away. Rather, it is just cycling within a circumference region. So this human has not moved away. So it's not that it is moving with the ambulance. If you are moving alongside with the ambulance, you will keep still seeing the lights flashing red. But by the time the ambulance is moving, but you are still at one place, the color of the ambulance becomes faint and faint and faint, faint and vanish. So that is what we assume, that the galaxies has this color of light and they are red. So as the galaxies red lights, we're supposed to be observing it. Based on astronauts, they're supposed to be observing this red light of the galaxies. But we have noticed, scientists have noticed that there is a shift. The red lights have shifted. It is no longer as intense as we used to see them in some years back. There is a reduction in the visibility because there's a decrease in the frequency of the lights. There's a decrease in the intensity of the light. The light is still shining. The galaxy is still beeping. This is red light, but we on Earth, we are no longer observing it by the help of the instrument, whatever they are using to observe. They observe that these red lights of the galaxies are actually shifting and shifting and shifting and shifting, that they are no longer as glowing as we used to see them. That certainly means that there is a movement, that the galaxies are moving. So this evidence 2 proves evidence 1 that says galaxies are moving away. Then evidence 2 is telling you, if you don't believe it's moving away, at least believe in the Doppler redshift, that the red light of the galaxies are actually far away from us. They are not approaching us. They are moving away from us as we see the frequency of light decrease. When frequency of light decreases, it means you can't see it as sharp, as intense as it is. So this proves that the galaxies are actually moving. Let's look at point 3. If the universe was initially very, very hot, as the Big Bang suggests, remember, from the beginning of all things, universe was very, very hot. That is why there was nothing in the universe. It was complete zero volume. It is so hot that anything that would have existed would have been vanished, would have vanished. If you use the word turn to vapor, that is an understatement. They vanished. They are not in existence. Proton did not exist. Neutron did not exist when the universe was very, very hot. Very, very, there is no figure on Earth that quantified the degrees Celsius. It is more than trillions of degrees Celsius that the universe was as hot as. So there was no possibility for anything called matter to exist. There is no possibility for any so-called thing. Sun, in fact, the sun is not even compared to the hotness of the universe in the initial state, according to the Big Bang. If there was a sun that existed and the universe was as hot as that, the sun will vanish, the sun will explode and go out of materialistic. it will not be a material again. It will go out of extinction. It will go out of existence. That is when you know what they call that hotness past hotness. You think you are hot until you meet something that is hotter than you, million more hotter than you. So at that point, zero volume universe, nothing was in existence inside the universe, but there was energy. Energy is the hotness. Energy, remember, heat is an energy. Remember, heat is an energy. So when we say it was hot, it means it has heat energy. So energy was also the only thing that could exist because it's a form itself. So we should be able to find some remnants of this heat. If the Big Bang says that the universe was this hot, how come all of a sudden we can't feel this heat again? If we cannot feel this heat again, that means it is a lie. But if we can still discover some amount of intensity of this heat, we have to believe it. At least we can have a remnant of this heat. In 1965, this background heat, now termed what you call CMB. You must have heard of cosmic microwave background radiation, CMB, which spreads through observable universe. We have discovered this today. CMB has been discovered today. Some said they just call it a wave of heat. CMB is so powerful and is observed in the universe. Now the universe is cooling, but there is still a wave of this heat that it had initially. So if this universe was this hot, the hotness is responsible for expansion. There is a remnant of this heat, and it's in 1965, it was observed as a background heat. The cosmic microwave background radiation was discovered to be spreading in the universe. So this is the third evidence. And the fourth evidence is abundance of light elements, hydrogen, helium, that are found and observable in the universe. They are thought to support the Big Bang theory of origins. Remember, I told you, nothing would have existed if the universe was as hot as it was. But to prove that the universe started becoming cooler and cooler, things started forming. The protons begin to form and unite with the neutrons that were also formed. And there is how hydrogen and helium came into existence. So since hydrogen and helium exist, it shows that, oh, really, the universe was once hot. Oh, really, the universe started becoming cold. And now something is forming, and something that formed were the hydrogen and helium. They were the first observable formation of creation. Man was not the first thing or first matter to be created. The first matter that came into creation was hydrogen and helium. They are the only observable elements that you could have seen as the universe was actually cooling at that point. And we call them light elements. They are so light that their mass is so negligible. So these are the four major evidences. Number one, the galaxies are moving far away from us. So as they move, their speed increases. So it's as though they are trying to push away from the world. Number two, Doppler red shift is observed that the red light of the galaxies is as though they are far moving away, disappearing. If the lights are disappearing, it means that the galaxies are moving far from us. Thirdly is what you call the existence or remnant of the heat. We say the universe was once very hot. If it was once very hot, we should have been able to see some of this vapor or wave of heat somewhere in the universe. Yes, it was observed in 1965 of the CMB cosmic microwave background radiations was spreading and observed in the universe. That shows that this is actually true. Then also, we also heard about the Big Bang, that the universe got cooled and began to form hydrogen and helium. Today, we know hydrogen and helium exist. They exist in every matter. And For them to exist in abundance, it shows the Big Bang Theory origins could actually be right. So this is a summary of the Big Bang Theory and its interpretation. Number one, light from other galaxies is redshifted. Yeah, the interpretation is that the other galaxies are moving away from us. Two, the further away the galaxies, the more its light is redshifted. Interpretation, this means that most likely explanation is that the whole universe is expanding. If there's a shift, this supports the theory that the start of the universe could have been from a single expansion. Then cosmic microwave background radiation, CMB. The interpretation of this existence is that the relatively uniform background radiation is the remains of this heat energy that was created just after this Big Bang. So it's a Big Bang, it's a big expansion, a big growing. So the universe is expanding, it's a Big Bang. So expanding at an alarming rate. And the best way to describe this expansion is to call it a Big Bang. So we are going to be looking more. So the Big Bang is more than just expansion of the galaxies. The Big Bang theory exposes us to know that the universe is filled with something called dark energy. We usually believe that the universe is empty space. But now we are getting to know that this empty space that you called nothing are actually something, and they are billions. In fact, what do I mean? More than infinities of energy. All we could call them is dark energy because we can't see them, we can't handle them, we can't measure them. They are beyond the limits of any instrument to measure. What instrument do you want to measure that kind of energy? Instrument that runs from 0 to 1 million degrees C, instrument that runs from 0 to 1 million joules. How can you do that? You can measure that because this energy is so big. It is 68%, and you are just 5%, a remnant on the Earth. All right, next class we'll go deeper into some other terms. You will know the meaning of universe. We're going to define universe, galaxies, star, sun. We'll look at planets. What does it mean? Exoplanet, dwarf planet, moon, asteroid. And we'll look at the solar system, all the planets we have and the new ones that have been discovered. We'll talk about each and every one of them. It's going to be a very interesting topic. It will expose you to a lot of things that exist, how oxygen came into being, water, how food started growing, how sun produces energy. We'll look at all that in next class. We'll stop here for now. Good night. Have a nice